Alright guys, welcome to this page of the notes. What we're going to do is take a look at a couple more, what I like to call conceptual questions, dealing with mid-segments. And the reason I'm going to call it a conceptual question is really kind of this. We're not really going to be solving for a variable here. I'm not asking you to find a missing length. I'm just simply testing you on your understanding of mid-segments. Here's what I mean. Take a look at this question. I want you to explain why xy, all right, so this guy right here, this xy, is not a mid-segment of the triangle. I'm not asking you to find a missing length. I'm not asking you to find a missing value. I'm giving you a diagram and I'm asking you, do you understand enough about mid-segments to explain to me why xy isn't a mid-segment? So we take a look at it. And we spot our problem. Here's our problem. Remember, in order to be a mid-segment, right, the mid-segment must connect two sides of a triangle, which it does, but it must split those sides of the triangle in half, right? And take a look. I have 5 down here and 6 up here. Those things must be congruent. So in order for this to be a mid-segment, this would have to be congruent to this would have to be congruent to this, and they are not. 6 is not congruent to 5, right? 6 is not congruent to 5. So because they're not congruent, I know xy cannot be a mid-segment, and that's simply what we're going to write. Mid-segment must connect the midpoints of two sides of the triangle. That looks like an H. Let me change that to an M. The mid-segment must connect the midpoints of two sides of the triangle. In this case, x and y, they're not midpoints. So because x and y are not midpoints, xy cannot be a mid-segment. Therefore, xy cannot be a mid-segment. Sorry, I had to squeeze there at the end, but xy cannot be a mid-segment because x and y, they're not midpoints. How do I know they're not midpoints? Because the length above and the length below would have to be congruent, and they're not. So that's what I mean by conceptual. In this case, there wasn't any missing value that you had to find. Just based on the diagram, I'm asking you, do you understand mid-segments well enough to just be able to explain to me whether something is true or not? Yeah, great conceptual question. I like that one a lot. In fact, actually, I like this one a lot too as well. Here we go. I'm not asking you to find a missing length or a missing value or anything like that. Turns out I'm actually asking you something about perimeter. Let's see how this one goes. What I want you to do is explain how the perimeter of triangle DEF, let me put triangle DEF in red. It's right here. There's DEF, that triangle right there. I want you to explain to me how the perimeter of triangle DEF compares to the perimeter of ABC. Triangle ABC. So, how do the perimeters of the smaller triangle compare to the perimeter of the larger triangle? Okay, here we go. First, perimeter. Not too terribly tricky. Triangle DEF. In order to find the perimeter of triangle DEF, you just simply have to add together the lengths of all of the sides. Well, I haven't given you any lengths, so we'll just use segments, right? It's going to be the segment DE plus EF plus FD, whatever those links are, which I didn't give you, it doesn't really matter, right? You have to add together those three segments to get a perimeter. So it would be segment DE plus EF plus FD, or DF, whichever. We'll go FD. Right? I'd have to add together all of those segments. Okay, great. What about the other triangle? Well, triangle ABC, again, would be the sum of each of the links, right, of its sides. I didn't give you links, but it doesn't matter. So it would be side AB plus side BC plus side CA, right? I'd have to sum together all of those links. Now, here's where the conceptual part comes in. What do we know about the length of a midsegment? Well, the length of a midsegment is 1/2 the length of the third side. So, first, DE. DE is 1/2 of what length? DE is 1/2 of CA. So let's put that in there. Triangle DEF is 1/2 CA. Great. What about EF? Well, here's EF right there. That means EF is 1/2 the length of what side? The third side. AB. So it's 1/2 AB. Keep going. You're on a roll. You're doing great. FD. FD is right here. That means it's 1/2 the length of the third side, BC. Well, look at this. 1/2, 1/2, 1/2. All of those terms have a 1/2 in common, so we'll factor the 1/2 out. Triangle DEF is equal to 1/2 side CA plus AB plus BC. Now, what we're going to do is we're just simply going to use, right, the commutative property. Remember, the commutative property says it doesn't matter what order you add numbers in. This is actually the commutative property of addition. There's a commutative property of multiplication, but I'm not multiplying, I'm adding. What that allows me to do is rearrange the order of these guys, which I'll do. Let me just move them around. I'm not changing anything, just switching the order. 1/2 AB, side AB, plus side BC, plus side CA. Okay, now what do you notice about the perimeter of DEF and the perimeter of ABC? Hopefully you quickly recognize that this right here, the perimeter of triangle ABC, side AB plus BC plus CA, is exactly what I've got right here. Same. So, what is the only difference between these two equations? Cuckoo, that guy right there. Look at you go. So what do we know about the perimeter of the smaller triangle compared to that of the larger triangle? It makes perfect sense. The perimeter of the smaller triangle is 1/2 the perimeter of the larger triangle. So, triangle DEF. Actually, hold up. Sorry. Let me slide. I shouldn't say triangle. I should use the term perimeter because that's what we're talking about. So, the perimeter. Let me make sure we're right. Perimeter. Yeah, perimeter. Yeah. The perimeter of triangle DEF is 1/2 the perimeter of triangle ABC. Right, and we got that by simply looking at the perimeter. I found the perimeter of the larger triangle. Using the property of midsegments, I wind up with the perimeter of the larger triangle multiplied by 1/2. You just take half the perimeter of the larger triangle and you get the perimeter of the smaller triangle. Again, we didn't solve for any unknown values, we didn't find any unknown links, just simply using, do you understand the property of midsegments well enough to answer a question about a diagram, what I would call a conceptual question. Guys, thank you so much for joining me for this section on midsegments, as well as everything we've covered here in this chapter. Points of concurrency, solving for unknown values, and really just in general taking a look at triangles. I had a great time with you. I'll see you next time.